What if an AI could actually imagine something it's never seen before? Well, today we're going to dive into a groundbreaking new concept from Meta AI that's teaching machines to do exactly that. And honestly, it could change everything we think we know about artificial intelligence.
So, it all boils down to this one really fundamental challenge. How in the world do you teach a computer common sense? I mean, think about it. You and I, we just know that a dog has 4 legs and a tail, right? Even if half of it's hiding behind a couch. But getting a machine to have that same kind of intuitive grasp on the world, that's been the holy grail.
And here's the crazy part. The answer, it turns out, might not be about showing the AI more, but actually showing it less. The real key seems to be teaching it to predict what's missing, to literally imagine the parts of the world it can't see. And by doing that, it starts to build its own internal map of how things are supposed to work.
Okay, so to really appreciate why this is such a massive deal, we've got to take a quick look back at how AI has been trying to understand images up until now.
For years, there have basically been 2 main schools of thought, 2 competing teams, if you will. On one side, you had what we'll call the mimics, and on the other, the pixel painters.
All right, so the mimics. These guys learn by looking at the same picture over and over and over, but each time it's a little bit different. Maybe it's cropped or the colors are shifted. The whole point is for the AI to figure out the essential, unchanging catness of a cat, you know? But, and this is a big but, a human has to come up with all those little changes. And that means our own biases can get baked right into the AI's brain.
Then you've got the pixel painters. Now these models are total perfectionists. They learn by taking a chunk out of an image and then trying to repaint it, pixel by painstaking pixel. They're obsessed with the tiny details, but they get so lost in the weeds that they often miss the forest for the trees. They don't get the bigger, more abstract idea. And this really shows you the difference in their approach. On the left, you see the mimic strategy. Compare 2 things to find what's the same. And on the right, you've got the pixel painter's much more complicated mission of trying to rebuild a perfect image.
All right, so this is where it gets really interesting. What if there was a third way? A way to get the best of both worlds without any of the downsides? Something that could grasp the big picture like a mimic, but without all that human-injected bias?
And that's where I-JEPA comes in. I know, it's a mouthful. Image-based Joint-Embedding Predictive Architecture. But forget the long name. Just focus on that one word, predictive. This isn't about mimicking or painting anymore. It's about predicting. And that, my friends, is a total game changer.
So instead of looking at the whole image or trying to fill in missing pixels, I-JEPA gets just one small piece. We're going to call this the context block.
And from that single piece, its goal is to predict the idea of the other missing pieces. This is the absolute key. It's not trying to paint the missing pixels, it's predicting the abstract concept of what ought to be there. So the AI isn't operating with pixels at all. It's working in this high-level abstract place called a representation space. Just think of it like a map of ideas. It understands concepts like dog fur or car wheel without needing to know the exact color of every single pixel. It's all about the gist, the concept, not the tiny details.
And this is a great illustration of the whole process. You've got the context encoder. That's the part that sees what's there. And then you've got the predictor, which is the part that imagines the high-level ideas of what's missing. It's brilliantly designed to just strip away all the noisy, unnecessary details.
Okay, so that's the theory. But the big question is, does it actually work? Well, the results are, yeah, they're pretty darn convincing.
In head-to-head tests, I-JEPA consistently outperforms the old methods, especially the ones that don't rely on those handcrafted human shortcuts. This shows it's learning a much more genuine, deep understanding of the visual world, all on its own.
But here's the part that's just, wow, the efficiency. Because I-JEPA is predicting abstract concepts instead of trying to paint millions of individual pixels, it learns way, way faster. We're talking about getting these better results while training 5 times faster.
And that's not just a little bit better, that is a huge leap in efficiency. It means it needs just a fraction of the computational horsepower. Less GPU time, less energy, less money. It's just smarter.
Okay, now for the really cool part. What does this new power actually look like in action? Let's see what happens when we can literally watch an AI imagine.
So the researchers found something incredible. The model isn't just throwing spaghetti at the wall and seeing what sticks, it's actually capturing the structure of objects, producing high-level parts with the correct pose. It gets it. Let's make this concrete. Take a look at this example from the paper. Here's our starting point, a photo of a car.
Now this is what the AI gets to see. Just a few little pieces here and there. That's it. Most of the car is gone. A pixel painting model would have absolutely no clue what to do with this.
But from just that tiny bit of context, look what I-JEPA imagines. It's not trying to create a perfect photograph. It's predicting the concept of the missing part. In this case, a totally plausible rear spoiler in the right spot with the right shape. It understood car and imagined a part that makes sense. That's what AI imagination looks like.
So, let's wrap this up. What are the big takeaways here? Well, first, I-JEPA learns these high-level semantic features without needing any of those human-biased shortcuts. Second, it's way more computationally efficient. And third, and this is the big one, it learns abstract ideas, not just pixel patterns. This is a massive step towards AI that has a more general, common-sense understanding of the world around it.
You know, this idea of teaching an AI to imagine the world, to predict abstract information instead of just coloring by numbers, it opens up so many possibilities. And it leaves us with one heck of a question to think about.